Hi friends, in this video we are going to discuss one important terminology used in the design of pavements, which is nothing but the modulus of subgrade reaction. If you have not seen this term before, let me just take you to the application of this particular term first. It is used in the radius of relative stiffness calculation. So this is another important term used in the design of pavements. Actually, this term radius of relative stiffness, this is the equation actually. We can make a separate video on this particular term. This is also one of the important topics from competitive exams point of view. This is actually used in the stress calculation. Okay, used in stress calculations of the pavements. Okay, especially in the rigid pavement, we are having the application of this radius of relative stiffness term as well as modulus of subgrade reaction. Now, in this equation of radius of relative stiffness, you can see the term K here, right? EH cube divided by 12K into 1 minus mu square. So this K is nothing but our modulus of subgrade reaction. Generally, we use the letter K to denote this term modulus of subgrade reaction. Now, the other terms I'm not explaining now. Later, we can make a separate video. So just understand the application before studying something. Okay, so this K is nothing but modulus of subgrade reaction. Now, first of all, we'll calculate our K. Then we'll be substituting that K value in this equation and calculate the L value. Generally, we use the symbol or letter L to denote radius of relative stiffness. Now, after calculating L, we'll be putting in the stress equations. We are having multiple equations given by Westergaard's and all. And in that equation, we'll be substituting L and calculate the stresses value. Then we'll be designing the pavement. That's it. That's the procedure. Now, how to calculate the K value? That is the first stage, right? To calculate K or find the K value of the subgrade soil, we'll be using the plate load test. We can also call it as load bearing test. Okay, both are same. Now this is a test setup which you can see on the screen. Now using this test, by conducting the test, we'll note down some values in the gauges. You can see some gauges here, right? Here you can see some dial gauges and all. Now in this we'll be noting down some values. Using those values, we'll be calculating modulus of subgrade reaction. So directly we are not going to get any value here. Okay, I mean directly we are not going to get modulus of subgrade reaction value here. We can use the symbol K to denote that. Okay, some other things we are going to note down, and using those values we are going to calculate the K value. That is the procedure. Okay, so you understand remember the name of the test, plate load test or load bearing test. But you see the same test you might have already studied for some other terminologies also, right? What are those? This is actually a soil mechanics concept to calculate the bearing capacity and ultimate settlement of the footing. We'll be using the plate load test or load bearing test. So this test setup is also called as load bearing test or plate load test. So both are same. Depends upon what you need to calculate. The test procedure will be varying. In both cases, we'll be calling the name as, or we'll be calling the test using the name plate load test or load bearing test, but the test procedure or test setup will be different. Here you can see we are making a rectangular pit, right? And at a particular depth only we are going to conduct the experiment. So this test setup you might have already studied in the soil mechanics subject. If not, you can just mention that in the comment box of this particular video. If you want explanation of this particular test and how to calculate the bearing capacity, how to calculate settlement and all, you can just mention in the comment box that you require that video also. Then I'll be making a video on this particular concept as well. Now, right now, I'm not going deep into this particular thing. Let's focus on our particular topic. Okay, I just want to let you know that this is also called as plate load test. But our plate load test setup is different because we are going to calculate another thing, not the bearing capacity, not the ultimate settlement. We are going to calculate a term called as modulus of subgrade reaction. So the entire test setup is different. Now, previously we were using a square plate, which I have shown you just now. Right now, we are going to use a circular plate. You can see here, right? A mild steel plate we are using, which is of circular shape. Now, whenever we are having a circular plate, generally using the diameter of that plate, we'll be representing that, or we'll be denoting that plate using the diameter. Okay, using the diameter only, we'll be representing the plate. If I'm telling the diameter of the plate is 75 centimeter, what is the meaning of this? A large mild steel plate I'm using, which is having a diameter of 75 centimeter for conducting this test. This is actually called as the standard size of the plate, or it can be considered as the standard plate. That's it. Okay, so this is the standard plate in plate load test. In which plate law test? The plate law test which we are using to calculate modulus of subgrade reaction. In the other one, it is different. Okay, we can discuss later. Now, standard plate in the plate load test to calculate modulus of subgrade reaction is a circular plate having diameter 75 centimeter. Or in other words, if they are asking what is the standard size of the plate, then it is 75 centimeter diameter, not radius, diameter. So in the options, if they are asking such questions, sometimes they can ask you the radius also. What is the standard radius? Then the radius will be 37.5 centimeter. Understood? Like that. But generally we use diameter only to denote that. So it is 75 centimeter. Remember that. That's the first point. And it is circular shape. Understood? Now, what actually we are doing here, that also you need to understand. See, you can see a load giving mechanism here. On that mechanism, we are going to apply the load. We'll be giving the load to the subgrade soil. You can see the soil here, right? Right? I hope you're able to see the soil. So on the soil only, we are going to keep our plate. Now, why we are keeping on the soil? Because on the soil only, we are going to conduct our, or we are going to construct our road. Okay, so wherever you want to construct your road, on that particular soil, we call it as subgrade soil, right? On that particular subgrade soil, we need to conduct this experiment. Then only we'll be understanding the properties of that soil. Okay, whether the property of soil is okay or not, or what is the actual value of modulus of subgrade reaction of the soil on which we are going to make our road, right? Based on that only we need to, decide the thickness of the road and all. No, that's it. Okay, so a load we are going to give on this mechanism, and that mechanism will be transferring the load on this circular plate of diameter 75 centimeter. Understood? Now, whenever we are giving a load on this plate, definitely this plate is going to apply that load or transfer that load on this subgrade soil, right? Understanding? So there will be a deflection happening from the original location. Understanding? Settlement or deflection, anything we can say. Generally, we use the word deflection. That's it. Or deformation, like that also we can call. Now, that deflection also will be measured in this dial gauge reading. Okay, too many dial gauges we are having. So, load and deflection. These two are the things that we are going to measure. Now, corresponding to a deflection of, I can just use the symbol delta. Corresponding to a deflection of 0.125 centimeter, or I can say corresponding to a deflection of 1.25 millimeter. This is a very important point. You need to note down. Okay. So one is the diameter. Second thing is the deflection. So corresponding to 0.125 centimeter deflection, we are going to check how much load we have given, or that you will be understanding in the, if you are looking at the dial gauges. Understanding? Okay. So the load corresponds to, the load corresponds to this particular deflection. See, as the deflection increases, load also will be increasing. Actually, it's opposite. As the load increases, deflection also will be increasing, right? Initially, it is at the normal original position. The load is 0. As you're slightly increasing the load, deflection also will be increasing, right? Because it is going down right now. So as the load increases, deflection also will be increasing. Now, whenever the deflection is becoming equal to 0.125 centimeter, or I can say 1.25 millimeter, that particular load we are going to note down. Now that load is what we require from this test. Now, once you are getting the load, what I can calculate? From the load, I can calculate the corresponding pressure, right? Why I am calculating the corresponding pressure? Because the modulus of subgrade reaction K is given by pressure divided by the deflection. Now this deflection value is a standard value. What is that standard value? Whatever pressure you are getting corresponds to the standard deflection of 0.125 centimeter. Now the deflection in any unit you can substitute either mm or centimeter or meter, anything. But generally we calculate the value of K in terms of centimeters. That's why anything you can substitute, doesn't matter. But this value is a standard value or standard deflection. That's what we have discussed now. Okay, now how to calculate the pressure if I'm just keeping it as a P by delta, something like that. Delta is 0.125. Now how to calculate this pressure P? Pressure is nothing but load by area. We know that, right? Load by the contact area. But sir, how to calculate the contact area? Will they give in the question? No, absolutely no. Then how we are going to calculate the contact area? The load we are going to note down from the dial gauges. The contact area is nothing but it's a circular plate, no, having a diameter D, right? Now, if the diameter is D, then what will be the contact area? That is pi by 4 D square, where D is the diameter. But sir, you told that the standard size is 75 centimeter. Then the contact area also will be standard, no? Pi by 4 into 75 square. That will also be standard. But actually, even though the standard diameter is 75, it is not mandatory that we have to use 75 centimeter always. You can use 60 centimeter dia also. You can use 45 centimeter diameter plate also. You can use 30 centimeter diameter plate also. Like that, so many diameter, small plate also available for the test. You can use any diameter, no issue. The standard diameter is 75. But if you are using different diameter, the values of load also will be changing, no? Yes, of course it will be changing. Then the K value also will be changing, no? Yes, K also will be changing. Then why we are keeping a standard size or standard plate size? If you want to use the K value in this particular equation, the radius of relative stiffness, for this K, you have to calculate the value corresponding to 75 centimeter dia only, which means K, I can just simply write like this. Okay, which means this K is only corresponds to 75 centimeter dia. Then in case, if you are using some other diameter, okay, some other diameter if you are using, let it be, I'm just putting it as some D1 like that. Okay, just a second. Okay, just let me take an example. If this is, for example, 60 centimeter dia. Now, correspondingly, you can calculate a K value, no? I'm just denoting it as K60. But this value, I cannot substitute back to this equation of EH cube by 12K. I cannot substitute. Then what to do? Using this value, by applying a correction, I need to calculate the value corresponding to 75. Which means, suppose if I were using a diameter of 75, what value I might be getting? That value I'm going to predict using the obtained value by applying a correction. And what is that correction? That is very simple. We can just remember the formula. K1 D1 is equal to K2 D2. Which means if we have a diameter D1, according to the example, it is 60 centimeter. And let's say you got some value K1. Okay, I can just keep it as K60. So K1, D1 in the sense K1 into D1, okay. So the obtained value into diameter, the used diameter will be equal to the standard value which we require is 75, the value corresponds to 75 dia. So the value which we require in this equation, K75 into 75. By applying this correction, which means The K75 which we need to substitute in this equation will be the calculated value from the test into the used diameter divided by standard diameter. So like this, a correction we are going to apply finally, and this obtained value only we can substitute in this particular equation. Okay, so we can use, we can do a question also. Okay, 3 different questions we are going to solve, level 1, level 2, level 3. So this is kind of a level 3 question, which we will be solving as the third question. Okay, I hope you understood the concept. Now let it be there. Now, coming back to the explanation, that is why I have not written 75 here as a standard, because this diameter can be any value. It can be 30 centimeter, 45 centimeter, 60 centimeter, 75 centimeter. These are the general diameters of the various plates. Okay, whatever they are giving in the question, we can calculate it. Okay, now whatever be the diameter, a corresponding K value you are going to get. Understood, guys? Very simple concept. Now let's understand it by using a question. Okay, help of a question. Now the question is like this: a plate load test is conducted to find the modulus of subgrade reaction of the soil, which means it's going to be a circular plate now, using a standard plate. Okay, now no need of applying any correction here, because we have used already the standard plate itself. What is the meaning of this? From this statement itself, I am going to understand that the diameter of the plate is going to be 75 centimeter. That's it. Okay, now the stress required to make a plate deflection of 0.125 centimeter is found to be 0.1 megapascal. So now, should we calculate the contact area? Not required. Why? Because they have already given the stress value. Stress means pressure value. Already given directly. How much it is? 0.1 megapascal. Okay, now how to calculate the K value then? K is equal to pressure divided by deflection, P by delta, I can write like that. Now 0.1 megapascal divided by deflection 0.125 centimeter or 1.25 mm. But we require the value in kg per centimeter cube. Look at the unit. This is actually previous gate question. See, the pressure will be, if I am substituting the pressure in kg per centimeter square, and if I am substituting the delta value in centimeter, in which unit I am going to get the answer? Kg per centimeter cube, right? Okay, so which means if they are asking the value in kg per centimeter cube, I need to convert this pressure into kilogram per centimeter square term. The deflection already it is given in centimeter only, or else it's a standard value, even though they are not giving that value in the question and just mentioning standard deflection. Then also we know that it is 0.125 centimeter. Now this P value we need to calculate in, or we need to convert into centimeter square. That is the challenge here. That's it. So for that you should know what is the meaning of megapascal. So 1 megapascal means 1 Newton per mm square. That's a very important relationship that you need to remember. Okay, so 1 megapascal is nothing but 1 Newton per mm square. So 0.1 megapascal is given here. So that 0.1 we need to convert. Okay, now 0.1 into, how to convert Newton to kilogram? How to convert Newton to kilogram? We need to divide with 9.82. Right? Newton is equal to mass into G. Right? M into G. So this Newton we need to divide with 9.81. Once you are dividing with 9.81, we are going to get in kg per mm square. But we need in kg per centimeter square. Then what to do? 0.1 divided by 9.81. Now it is in kg divided by centimeter square. No, so 1 mm is 0.1 or 10 raised to minus 1 centimeter. Now the square of that. So 10 raised to minus 2 will come. The 10 raised to minus 2 is on the denominator, that will go up. See, this much in detail I don't have to tell you, like spoon feeding. In case if anyone is having doubt, let them clear it. Okay, that's why I'm just telling in this much, in detail. So once you are doing this, you are going to get 1.019 kg per centimeter square. That's it. Now that value you need to substitute back to the equation 1.019 kg per centimeter square divided by 0.125 125 centimeter. Now the obtained value, which is 8.1549, is going to be in the required unit, kg per centimeter cube. So approximately 8.15 will be our final answer. Understood, guys? So this is how we are going to do. So properly check in which unit they are giving and what they are giving, whether stress or load. Okay, that's it. And also whether the standard diameter plate they have used or not. These are the things that we need to check. Now the level 2 question. Look at this question. Same kind of data, but the thing is the load value is given here. Or also from the unit and all, you can understand that if it is a stress, then divided by mm square or Newton, what I can say, centimeter square or meter square, like that they will be giving the data. Okay, now 3200 kg is the data. Sometimes they can give in Newton also. I will be giving a question like that. Okay, Newton or tons, like that also they can give. Properly you need to convert. Okay. Now load is given here corresponding to the standard deflection. We need to calculate the modulus of subgrade reaction. Now which diameter we have used here? They didn't mention anything, but they have mentioned that it is standard plate. So if it is standard plate, then diameter is 75 centimeter, like the previous case. But in the previous question, they have mentioned the stress value, but in this particular question, they have mentioned the load value. Then one additional step we need to do. What is that? The P value we need to calculate first. What will be P value? Load divided by contact area, right? So the load is 3200 kg divided by area will be pi by 4 d square, nothing but 75 square. So you are going to get in kilogram per centimeter square. This 4 you can take above, whatever, up to you. The calculations and all you know. You are going to get 0.7243 kilogram per centimeter square. So unit is very, very important. Okay, load is in kg, 75 is in centimeter. So square we are doing. So centimeter square will be getting. Actually, this load, this stress value, you don't have to calculate separately. We don't require this value, no? Why? Because we require this pressure by delta. So directly you can do the calculation. Like once you're obtaining this value, no need to note down that value. Once you are getting it, directly you can divide the value with 0.125. Now why 0.125? That is the standard deflection, and also that is in centimeter. That is also important. Both should be of the same, same units. Same unit in the sense, same terms. Okay, centimeter, like that. Now once you are doing this, you are going to get 5.7946 kilogram per centimeter cube. That's it. Okay, if there is any slight variation in the calculation, forgive me, you can just calculate it. Hope you are understanding the concept. Got it, guys? This is the level 2. Means instead of giving you the stress value or pressure value directly, they will be giving you the load value. Using the load value, we can calculate the pressure value. And don't forget to divide with the standard deflection. That's the thing. Okay, now the next level of question, level 3. Look at here. Here, the diameter of the plate is not 75, which means it is not standard plate. Then what it is? It's a 45 centimeter plate. Now, why we are using a non-standard plate? Like why we are not using a 75 dia plate? Because a 75 centimeter plate will be somewhat heavier. It's a mild steel plate, no? Somewhat weight will be there. Obviously, cost also will be higher. And also, it will be somewhat difficult to handle properly. That much size it is having, no? Just imagine 75 centimeter dia. To handle it will be somewhat difficult. To place it properly on the ground, handling will be difficult because it will be heavy. That's why. So sometimes we may be using somewhat a lesser dia plate for simplicity in the test. That's it. Okay, for doing the test. That's why. But no issue. Later we can convert that into standard plate. Then what is the point of using standard plate every time? That's it. So here 45 centimeter dia plate we have used, and they have given the load in. The value is 1.6 tons. Means what? That is the load value. So here two things we need to do. First of all, convert that load into pressure. Second thing, after obtaining the K value, we need to change or we need to convert that for the standard plate. Otherwise, there is no meaning of calculating K value. The K value should be for the standard plate only. Then only there is an application for that. Otherwise, just after calculating, why you are calculating? It is just waste of time. So for such question, definitely they are going to ask for the standard plate only. Got it, guys? Now, what we are going to calculate as of now, I'm just keeping it as K suffix 45 because it is for the 45 centimeter dia plate. So P by delta. Now, how much will be that P? That P will be the load 1.6 tons divided by pi by 4 into 45 centimeter dia plate. So 45 square. That's it. Now this ton we need to substitute to kilogram, right? Then only we are ultimately going to get kg per centimeter cube. Now 1 ton is how much? 1000 kilogram. That thing you should know. Okay. So 1.6 into 10 raised to 3 or 1000 kilogram divided by pi by 4 into 45 square centimeter square. Calculate that. I already told you no need to calculate and write it separately because we ultimately require this value divided by 0.125. But just for your comparison, we can calculate and just, in case if you are getting a wrong answer and all, okay, you can just understand that you have made a mistake like that. I'm just writing it 1.6 into 1000. That by 4 will go up into the numerator. Now divide by pi, divide by 45 square. You're going to get 1.0060 something like that. No need to round it off. Directly what you can do, we can calculate here. So this value 1.006 something like that divided by 0.125. Directly you do that 0.125, you're going to get 8.0481 kg per centimeter cube. Now, is there any practical application for this particular value? No, there is no practical application. Then what we need to do? We need to change it to 75 centimeter diameter. That's it. That's what we have discussed before. Now, how to do that? The obtained value, which is 8.0481 into its corresponding diameter, which is 45 centimeter. Unit is also important. Okay, unit is also important. Is equal to the value which we require. Then that will be in the same unit, kg per centimeter cube into the diameter. What is the diameter? 75 centimeter. That's what. In case if they are giving like the 45 centimeter, they can also mention it 450 mm or 0.45 meter. In that case, don't substitute 0.45 there. Okay, it is 45 because otherwise what you can do, the standard diameter you can keep as 0.75 meter. Okay, unit should be same. That's all. Okay, in that case, the required value K75 means for the standard plate. What is the value? K75 is going to be 8.0481 into 45 centimeter by 75 centimeter. Now that centimeter, that unit will get cancelled. Sorry. That's why I told you, you can substitute in meters also. No issue. That will be getting cancelled. Only thing is, both should be in the same unit. Now this 8.0481 is in the kg per centimeter cube unit. The obtained value also will be in kg per centimeter cube. Now that is going to be now 4.8288. So let me just clarify. So that into 45 divided by 75. 4.8288 kg per centimeter. Understood? Obviously, you are going to get a reduced value. Okay, that's it. So this is how we are going to calculate the K75. And this 4.8288. This value is what we are going to substitute back to this equation. Okay, 4.8288. You shouldn't substitute that 4.8288. You shouldn't substitute the value 8.048, which we have calculated for 45 centimeter. This value you shouldn't substitute here. Okay, this should be always of 75 dia. That's it. Okay, actually here in this equation, this mu stands for Poisson's ratio, E stands for modulus of elasticity of the concrete, and H stands for the thickness of the concrete, slab. A rigid pavement generally we make as a slab. So H is the thickness of the slab. So this equation is actually for the rigid pavement construction or design of rigid pavement. That's the application. Okay. So I hope you understood the calculation of modulus of subgrade reaction. Always remember, plate load test can be used in two different ways or can be conducted in two different ways. The circular plate we are using to calculate the modulus of subgrade reaction, and the square plate inside this pit. This is a square pit, right? Inside this pit at a particular depth, we are having the plate. Okay, that will be a square plate, obviously. So that kind of test setup or test procedure we are using to calculate the bearing capacity and ultimate settlement. Okay, this will come in the 14th chapter of soil mechanics or foundation engineering in soil mechanics. Okay, so that's it. I hope you got the clear picture regarding this term, and I hope you have enjoyed the video also. So thanks for watching. In case if you have liked the video, if you have enjoyed the video, show your love in the form of likes and comments. Please give your feedback in the comments and also share the video with your friends. Thank you so much.